Hello there, 6th grade. Welcome to Star Wars Week. If you don't know why it's Star Wars Week, it's because it is May the 4th, so may the 4th be with you. This week we're going to be covering two sections in one, and you're only going to have the one assignment for it. So 731 and 732 are sort of very complementary sections. They cover the same topics, and so we're just going to be going over one of them for homework this week. The rest of the time that you have this week when you're not doing math is to catch up on anything you are missing or working on. So use this time wisely. We're going to kind of be taking the week easy. So let's get started on here with section 731. We're going to be talking about inverse operations, and specifically we're going to be talking about how to write expressions with unknowns, and then how to take those unknown values and basically come up with ways to undo problems. This is really important for solving equations later on, so make sure you keep track of what we've got going. Here's what I'd like you to do first. I would like you to follow these steps that are in order on the screen right now, and I would like you to pause the video while you do that. So I'm going to walk you through it if you just want to listen and walk through it. So I'd like you to pick a number and write it down on your piece of paper. I'd like you to add 5 to that number. I would like you to double the result that you got. In other words, multiply your answer by 2. I would like you to subtract 4 from whatever you have right now. I would like you to divide that answer by 2. I would like you to then subtract your original number. And you have 3. If you did not get 3, go back and walk through those steps again, and feel free to try a different number if you'd like. But you're going to get 3. So what's happening here is you are, even though you can't see it when you're writing out in words, you are performing inverse operations on the math. So what I'd like you to do, if you need to, is try a couple of different numbers and see that you always get 3. You're going to pick a number, add 5, and I'm happy to walk through one of these. I will pick whatever number. Let's see here. How about first number I see on a paper over there is 10. I'm going to pick 10. Going to add 5 to that to make 15. I will double that by doing 2 times 15 to get 30. I will subtract 4. And I will have 26. I'm going to divide that number by 2 to get 13. Then I'm going to subtract the original number, which is 13 minus 10, putting me at 3. So what happens here is you are performing inverse operations whether you know it or not, or whether you don't know what those are. We are going to try to come up with ways to represent this using mathematical symbols. And what we're going to do is we will also write it out with algebra tiles. So I like using algebra tiles at the start because even though you don't have them physically with you, it shows you a good way to see the missing numbers. So you're going to start off in this problem where you're looking at this, you say pick a number, and when somebody picks a number, you need to think of it in this algebra tile problem as an x value. So pick a number means to choose an x value. And let's not pick 10 this time because we already did that. Second number I see on that paper is 4. So let's walk through this the same way. If I pick an unknown value, which is x, and then I add 5 to it, this in this case would be 4 plus 5, which is 9. Doubling that would be 18. And if you look at the algebra tiles, it went from a number plus 5 to 2 copies of the number plus 10. That's why those values are increasing like that. Subtracting 4 means you're going to remove these 4 tiles. That's what they've drawn there. Dividing it by 2 means you cut out half of this line. You cut off half of the problem. and then they have the original number plus 3. Okay. And then lastly, when they subtract the original number, that's removing the x tile, or the unknown value. You remove 4 from this, and then you have 3 again. You can see that no matter what you end up starting with, you're always going to land on 3. Okay. What I would also like to point out then is that you can take these sorts of equations and these expressions, sorry, and you can turn them into algebra tile pictures. Now, I am not going to advocate doing that with algebra tile pictures simply because it is a lot to draw when you don't need to. It's a great resource to start, but in the long run, it's going to become a little bit challenging. So picking a number would be an x tile, which I'll draw for the sake of this problem. Adding a number would be the x tile with 2. Multiplying that by 3 is where it gets challenging. This is now going to have 3 x tiles in it, which is very hard to put in there. And then it will also have 6 of these tiles. Subtracting 3 means that you're going to still have those 3 x's, but then you're only going to have 3 here because you've removed those 3 right there. Dividing that by 3 means you're going to split this up back into one of those 3 sections, which is just an x tile and a 1. And then subtracting the original number leaves you with just a single 1's tile remaining because you have subtracted the x out of it. So no matter what you do when you're filling these tables out, you can draw the algebra tiles, but what I strongly recommend you start doing, and even as you do this, I highly recommend that you fill it out as if you are using just the variables. It's going to make this a lot easier for you. When it says to pick a number, the expression is just an x value. To add 2 to that, you have x plus 2. Multiplying that by 3 means you have 3x's plus 6, because it's 3 times x and 3 times 2. Subtracting 3 means you have 3x plus 3. Dividing by 3 is tricky, but it means you divide every number by 3. And you get x plus 1, because 3 divided by 3 is 1x. And then when you minus the original number, which is x, you're left with just the plus 1 at the end. So I personally prefer to write this out with just the letters. However, if it helps to draw the tiles for these, please do that. What you're going to do for this one, and this is one that I would actually like you to try to do on your own before I do this, I would like you to try to take the pictures on the right, and I'd like you to try to translate those into steps that are written out in words. And you can follow this along by picking a number if you would like. So if my first number was 10, for example, I'd like you to just pick whatever number you want in these 3 trials and try to write an expression that matches these. So if the first part is pick a number, the second step is add 4. Because they had the original number and then they added 4 to that. So try to finish out the rest of this and see if you can fill in all of those steps. And what's going to happen is, if they started with their original number, they could then come up with their original number by doing some of these tricks. So go ahead and pause the video and try that for a little bit. And I would also, if you've unpaused this, go back and try this with a fraction or a decimal or 0 and make sure that it works. Those are the 3 weird cases that you might have. So see if one of those will work. Okay. Now, you might notice as you look at these, and this is something that's discussed here in this problem, is that if you add a value early on in a problem, for example, step 2 is adding 2 to this, then later on they're going to subtract an amount. So you'll see that if they added 2 here in step 2, later on they subtracted something, in this case 3. When they multiply by 3 in step 3, later on they divide by 3 in step 5. That is an idea of inverse operations, which is what we're going to talk about right here. So an inverse operation is just something that undoes the other one. Most of you are already very comfortable with the idea that addition and subtraction are opposites, and multiplication and division are opposites. All that you need to add to your vocabulary and knowledge is that you can invert addition, and the inverse of addition is subtraction. The inverse of multiplication is division. And you could even get more specific. The inverse or opposite of dividing by 2 is multiplying by 2, or in other words, doubling it. The opposite of subtracting 9 is adding 9. And this is very logical as you start doing this. But keep in mind that these are operations that undo each other. If I said pick a number, for example 2, I said add 3 to it, congratulations, you're at 5, subtract 3 from it. Well, you're back at 2. If you add 3 and subtract 3, you've gone right back where you started. You could think of inverse operations as taking you from where you were, put you somewhere, then go back to it. So they're the opposites of those things. Now, the reason I wanted to combine these lessons is the idea that the distributive property is something that's very common, and you've probably already seen this concept before. And this distributive property is, let's look at this set of steps on 7-91. And it's a lot. Like, that is a lot of tiles, that's a lot of information, that's a lot of stuff there. So what you need to do is to think about, okay, let's just go algebraic expressions. Those are going to be your friends. So I've got these down here. Okay. You want algebraic expressions to be what you are using almost always. So walk through this with testing out a number. I will, for example, pick 10, but we'll go back and do those steps afterwards. So my algebraic expression, it says pick a number. I have a single x tile. My expression is x. Okay, that's pretty easy. My next step is x with a 1, 2, 3, 4, 5, 6, 7 additional tiles. So it is x plus 7. And let's go with my trial here is 10 plus 7 is 17. Oh boy, that's a big number. Oh well. Now, this step right here, where it says to triple the result, you realize that to triple something is to just multiply it by 3. So if I took 3 times 17, okay, 3 times 17 is 51. You can look back and say, okay, well, how do I show triple the result right here? One way to do it is to look at it visually. Well, you've got an x and 7, and now you've got 3 x's, okay? And now you also have, these are each 7, 3 x's plus 21. Okay, that's pretty easy when you look at it that way. Now, they added 9, but they broke it up into 3 groups. So that's going to put me to 60. This is now going to be 3x plus 30, because 21 plus 9 is 30. And now when they divided by 3, you go back and they say, well, I went from 3 rows that are the same. Dividing by 3 puts me to one of those rows, which is now x plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it says to subtract the original number. There's my 60 divided by 3 to get 20. Subtracting the original number, which was 10 in our case, left you with 10. Here, the answer is always going to be 10 because you just subtract the x value away from it. Now, perhaps 10 was not an ideal example just because we ended up with the same thing. You can pick any value and you can walk through these same processes, and each and every time that you do this, you're going to get the exact same value of 10 as your answer. And you're welcome to walk through those if you'd like, where you've had a number and you do that steps, that's fine. But what's going to happen is each time you do this, you're going to get 10. So in this problem, there are inverse operations. But I would like to draw your attention back to this part where it says 3x plus 21. There is another way that you could write triple this value of x plus 7. Okay. When it says to triple an x plus 7, and I'm going to put that in little quotes because it's you're tripling the entire thing, the way that you can write this in this distributive property is 3 times an x plus 7. If you think back, you've had homework assignments that discussed the distributive property, and it might not have been something that you were even aware of that you were seeing. For example, if I had 10 times, you need to stop picking 10. Let's pick 7. If you had 7 times 36, this might not be a very easy multiple early on, because you're like, oh, I got to write it out, I got to do long division. But you may have seen this problem written as 7 times 30 plus 6. Those problems were not there to waste your time. They were there to show you a method, in this case the distributive property, where you could write it as a number times two separate things. Because 7 times 30 is 210. And then 7 times 6 is 42. And when you add those together, you get 252. And it was honestly a little bit easier to do it that way than it is to multiply 7 times 36 here. Unless obviously you have a calculator or photomath, whatever you're using. So this is the main idea that I wanted to show you, is that this expression, 3 times x plus 7, is identical to 3x plus 21. And it's because this 3 got multiplied into there. 3 times x is 3x, and 3 times 7 is 21. And that's the big idea from there. For the only other problem here that I want to talk about is I would like you to take 7-92 and try to write out the steps for this and do another algebraic expression. Okay, try something out. Try to write those out. Now I'm going to jump into the homework help. I know this video ran a little bit longer, but 7-96 is going to follow the same thing that we have talked about already. We've already talked a little bit about this. So we've been doing this. I want you to take this expression and turn it into steps. The one that I will tell you is that if you are seeing this one, which is 6x, this really means 6 times x. Even though that little multiplication dot is not written there between the 6 and the x, anytime a coefficient, which is just a number like 6, is attached to the variable, again, x is our variable, that means multiplication. So this means 6 times x. So in terms here, x is pick a number, and the second one is multiply by 6. Okay. And try out a couple of trials for these. Try out both of those trials. Now it then says to 7-97 is translate the situations into a variable expression. Anytime says the word variable, you need to think about the letter x as what's showing up in this problem. And in this case it says to pick a number. Great. Pick a number, you put an x on your paper. And multiply it by 7. So put a 7 in front of it to represent 7 times x. And you can write that just as 7x. But again, anytime you see the 7 next to the x, that means multiply. This says pick a number. Great, I've picked x. Add 2. Okay, I can do that. And it says then multiply by 5. This is the tricky part. When you multiply by 5, that means to take everything in this problem and put parentheses around it, and then you multiply by 5. You can also write this as 5x plus 10 because it is 5 times x, which is this first value, and then 5 times 2, which is your second value. I will also take a slight detour in this problem to show you this property somewhere else. Way back when, we did these area models where you multiplied things like 10 plus 2 times 5, which is another way of doing 5 times 12. And we would multiply 10 times 5 to get 50, 2 times 5 to get 10, and then you would get 50 plus 10, and you would get 60. And this was very easy for most of you. But I want to show you that let's just get rid of the numbers in this. Let's go all the way back and say instead of 10 plus 2, you were really multiplying an x plus 2. Now, 5 times x is the same process you did before. 5 times x is just 5x. 5 times 2 is just 10. And it is the same process. These are all three equivalent ways of doing the same thing. But it's just a relationship that you may not see as this distributive property is one that you've already been doing. It's just been a while. Now, a portion web is to represent 0.33, or in other words, 33 hundredths. Don't forget the words in here. The phrase hundredths, there's 2 decimal places. You should just write this as 33 over 100. And then there's a very easy conversion there. For 7-99, I would like you to simplify the fractions. So first, I'd like you to simplify this fraction using the flip and multiply method, or invert and multiply. You can write it as 3 over 7 times, this fraction is what flips and becomes 5 over 2. For the second one, you cannot multiply a fraction unless this is now a improper fraction, or one fraction instead of a mixed number. 3 times 1 is 3, plus 1 is 2, or plus 2 is 5, times 9 over 10, and then you can just multiply through. On part C, I will give you a word of caution. Do not do 45 minus 2 first, and in that same vein, do not do 6 plus 4 and call it 10. You cannot do that. The very first spot you look is your following PEMDAS. Please excuse my dear annoying sister. And it's the parentheses first, and you look in the parentheses first. There's no exponents. There is multiplication. So I do 4 times 3 to get 12 first. And then you continue the problem. You go back to the parentheses, then do the work inside. This one, you're trying to figure out how to make these equivalent. So how do you take a 30 and change it into a 6? You divide by 5. So if I divide this by 5, I have a 7 there. Do that process for all three. Match things up. Figure out what to change from one to the other. You will start getting questions eventually that look like this. And if you have this skill down, you can save a lot of headache when you're trying to solve them. So that's all I have for you. I know this video ran long, but it's your only one this week. Use your time wisely. So finish the rest of your work, finish anything you are missing, and good luck, 6th grade.